Welcome to The Explainer. Today, we're going to talk about something that sounds like pure science fiction. Building a star right here on Earth. But it's real, and it could be the key to, well, basically limitless, clean energy for everyone. Okay, let's get one thing straight right off the bat. We're talking about a tokamak, not a tomahawk. One is a fusion reactor, the other is a missile. Totally different things, believe me. Right, so why? Why go to all this trouble to build a tiny star? Well, it all boils down to one thing. Our world is hungry for power, and we need a way to get that power that's clean, safe, and doesn't run out. And that's where fusion energy comes into play. It's literally the same thing that powers the sun. You take tiny atoms and you squeeze them together to release incredible amounts of energy. And if we can pull it off, we're talking about the holy grail, an almost endless supply of fuel, way less radioactive waste, and no chance of a meltdown. It's a total game changer. But here's the part that'll really blow your mind. Let's talk about the fuel. If you take just 1 gram of it, okay, that's about the weight of a paperclip. That 1 gram has the same energy as, wait for it, 2,400 gallons of oil. Think about that. A paperclip's worth of fuel could power your house for years. That's the kind of power we're talking about here. It's just insane. Okay, so it sounds amazing, right? But here's the catch, and it's a huge one. To get this reaction going, you need to create temperatures hotter than the center of the sun. We're talking over 100 million degrees. So what do you put that in? Any material we know of would just poof, vanish into a cloud of gas instantly. So how in the world do you contain it? Well, if you can't build a box out of stuff, you gotta build it out of forces. And that's exactly what scientists did. They came up with this brilliant idea called a magnetic bottle. See, when you heat the fuel up that hot, it doesn't just melt or boil. It turns into something else entirely. The fourth state of matter, called plasma. And all you really need to know about plasma is that it's basically a super hot gas where all the particles have an electric charge. And because they're charged, you can control them with magnets. And that is the solution. It's this amazing machine called a tokamak. Basically, it's a donut-shaped chamber surrounded by super powerful magnets. These magnets create an invisible force field, a cage that grabs hold of that super hot plasma and just floats it right in the middle of the machine so it never, ever touches the sides. And this is what one looks like on the inside. It's not just a simple donut, right? This is hands down one of the most complicated things humans have ever tried to build. Every single wire, every single tile has to be perfect to keep that little star contained. Okay, so you've built your magnetic bottle. Great. But now comes the really hard part. You've basically trapped a tiny, angry star, and now you have to tame it. Yeah, that plasma, it's not just sitting there quietly. It's more like a raging, turbulent hurricane of energy that is constantly trying to break free. And if it does, even for a split second, it can slam into the wall of the machine. They call that a disruption, and it can release so much energy, it can actually break the multi-billion-dollar machine you just built.
So this is what it looks like from the inside. And the whole game, the entire challenge, is to keep that miniature sun floating perfectly in the middle of this room without it ever touching the walls. So how do you control something that's this wild and this fast? You can't have a guy with a joystick. Things happen in millionths of a second. You need a pilot that's faster than any human could ever be. You basically need the reflexes of a Top Gun fighter pilot, but on a totally different level. The system has to watch thousands of things at once: pressure, temperature, the shape of the plasma, and make thousands of tiny corrections every single second. And it has to do it all on its own, spotting problems and fixing them before they even really start. And this is where AI steps in. It's really the only way. You need an artificial intelligence that can be that pilot, an AI that can actually learn how the plasma behaves, predict what it's going to do next, and then react in milliseconds to keep it stable. But that brings up another huge question, right? A really deep one. If you're going to give an AI the keys to a machine this powerful, a machine holding a tiny star, how do you know it's not going to mess up? How can you be 100% sure it will always be safe? You can't just cross your fingers and hope it learned the right lessons. The stakes are way too high. You need to be able to prove with absolute certainty that it will never do anything dangerous. You have to build the safety rules right into its digital DNA.
And the solution is this amazing new idea from mathematics called coherent spaces. The best way to think about it is like giving the AI a perfect, unbreakable rulebook. It's a way for the AI to look at the plasma, know exactly what's going on, see if it's getting close to a danger zone, and then this is the key part, prove, mathematically, that its next move is guaranteed to be a safe one. Now, look, the math behind this is super complicated, but the idea is pretty simple. It basically forces the AI to create a receipt for every decision it makes. And that receipt is a mathematical proof that what it's about to do is safe. It's like having a perfect referee watching over its shoulder that can't be tricked. So, let's recap. We've got this incredible promise of limitless energy. We have the super complex machine to make it. We have the wild plasma inside. We've got the AI pilot to control it. And now we have a perfect rulebook to make sure the AI is safe. So, what does this all actually look like in the real world? It looks like this: a project called ITER. It's being built in France, and it is one of the biggest, most ambitious science projects humanity has ever attempted. I'm talking 35 countries all working together, putting their best people and billions of dollars into building this one single machine. The goal? To prove once and for all that fusion energy can actually work on a massive scale. Now, it's super important to understand, ITER isn't going to be powering anyone's homes. That's not its job. Its job is to be the final scientific test. It's designed to be the first machine in history to create what's called a burning plasma. That's where the reaction basically keeps itself going, and to get 10 times more energy out than they put in. If it works, it'll be the blueprint for all the actual fusion power plants that come after it. Look, the journey to fusion power has been really long and incredibly hard. But when you put it all together, human creativity, countries from all over the world working together, and now these incredibly smart and safe AIs, we are seriously closer than we have ever been. So maybe the big question isn't if we can finally bring a star down to Earth anymore, but what it's going to change for all of us when we finally do.